Hi, I'm going to talk about Redux. And first of all, why do we need Redux? Normally, let me move this over a bit. Normally, we don't have to use Redux because React already has a way of storing state and passing state as props to the child components. But what happens if you have a more complicated structure? Let's say this state is basically data. Here's data. So here's with Redux. Let's say you have this sidebar needs to be updated with new data, and this blog also gets new blogs and new comments. That normally way, let's say this one needs latest blogs. Normally, to update it, you'd have state in this component and pass it as props to this child component. But similarly, you would need to set up state in this homepage component and pass it as props to this sidebar. The problem with that is you've got a lot of the same data needed by this and this, the latest blogs and sidebar, the two child components, but they're in separate trees. So you actually have to do, and they have separate parents, so you actually have to do double the work of setting up that data to go to this blog and go through to this latest blogs, and also has state in this homepage and pass through as props to this sidebar. That's a lot of work, and imagine if this was even more complicated app. The other way you could do it is actually if you set up state way up here in the top level, but then you got to pass it down twice. Pass it down to blog, and then from blog pass it down to latest blogs, pass it down to homepage, and later on pass it down to sidebar. And if you could also pass it from the data from blog really in a really convoluted way up to app and back down to homepage. So that's a lot of complication. Redux solves this problem by having a central data store. With this central data store, you no longer have to go this funny path from data from here up a level, down a level, down a level. You can go directly, whatever needs this state can tap into this global, well, why we need Redux for bigger projects. So take that out. We finished this. Here's the second part. Whoop. This, you can't just directly change the state. Here's a component. It just would be very disorderly and unorganized and dangerous if every component could directly change state, because it would affect other components, because that state is shared by everyone. So the procedure is this 4-step process. The component first has to dispatch an action. It has to, for instance, an action could be something called add post. It's basically in English, a human readable English term of what you want done. Add post. So that's something that a human can understand. You want to add a post. And with that action that you want, add post, you may need some data, which is called a payload. In this case, add posts, your payload will be the post. That's what this step does. So this action. And over here, the action I have here, for a different, instead of add post, I have increment or decrement. That's an action, a human description of what I want to do. Here, okay, I've defined the action. Dispatching action is now I'm telling the reducer that I want to do it. Yeah, so here is the dispatch. I've got an example of dispatching. Here's dispatch. I am store.dispatch increment decrement. So I'm telling it, yes, I want to increment. And then later on, I want to decrement. And then I want to decrement again. So it's 3 different dispatches. Increment, decrement, decrement. I'll show you another example. So here I defined, and now actually this is the reducer. So I'm telling it what to do. I say I want to increment, decrement, decrement. The reducer translates the human description into computer state equations. So increment. All right, that's what a human says, increment. What the computer interprets that as is, oh, increment is actually specifically state plus 1. In another example of a reducer, in this reducer is a counter reducer, by the way. There might be more than one function. So reducer can have many slices, meaning many different functions. This is the counter slice. So the counter slice has these 2 actions, increment, decrement. The decrement action, how do you describe that in terms of state? Decrement is a human readable form, human command. To the computer, that means state minus 1. So state minus 1. All right, so that's how, that's dispatching the action and interpreting as the reducer interprets it. Basically, the reducer takes the current state and an action and decides what is to be done. So it takes in the current state and an action. Current state and action. Finally, that is what changes the state. The state is changed because of the reducer. And after the state is changed, other components may want to know also what's going on. Because this state affects many components. One component may change the state. The other components will want to know if the state was changed. And they subscribe to the changes. Subscribe to changes means they want to know when the changes happen. And when they happen, they re-render. That's what subscribe is. So mystore.subscribe. Here I subscribe. I just console.log, but really that was just a debugging step. Really, if you subscribe, you may do more than just console.log. So let's move this over to the side. And let's see some more examples and interpretations to further explain. Here, the code, I have create store. And you get that I've destructured it from Redux. In its state, I have to-dos, which is empty at first, and posts, which is empty at first. Then here, I have a function called myReducer. This is an example of reducer. Like I said before, the state, in this case, it's set initially to something called init state, which makes sense. And action. The action will have different types. If the action.type is add to do, then return state. And this ... means take what is existing in state already and then overwrite with the new state. That way everything is accounted for. We take the existing state ... and update it with whatever is changed in the new state. Likewise with to-dos, we take the to-dos, we're taking ... the state of the current to-dos, state.to-dos, ... and just overwrite what needs to be overwritten. We overwrite what needs to be written with action.todo. Everything else about the to-dos remains the same. That way we know we don't forget the other stuff that hasn't changed. And here it's constant store equals create store myReducer. So you see create store takes only a single reducer. That's because it's a single argument. We cannot have many reducers at the top level because this create store only is looking for one argument. That's why when you have multiple reducers, you need to combine them using the combine reducer function. And you see here, the object to-dos by milk. This first example showed you what happened. This is actually an example of what happened if you didn't have the ... You would, if you changed to-dos, you would only see the new to-dos, but you wouldn't see the other stuff that didn't change, which was posts. That's why this actually is showing you. This is showing you what happened before this code, the ... was added. After adding the ... we ran it again, and you see the result is now it shows posts and to-dos. So it takes ... means start off not at 0, but start off with the old one and just update what needs to be updated. So the posts that were empty stays the posts that were empty, because that's part of your state. The above example before the ... is it completely forgot the posts, which is not right. Your state is including to-dos and posts. So now it's still to-dos and posts, just that to-dos is updated and posts remain the same. So let's get rid of this. Here's a line 3 to 19, so I already explained most of it, just some of these lines are new. Here it's just showing that you can have more than one action. Here action.type is add to do, but this action.type is add post. In both cases, you want to take the current state, ... state. The only difference is in the top one, add to do, you're changing the to-dos. So the to-dos was ... current to-dos, state.to-dos, and then change it with the action to do. This one for posts is you leave to-dos alone, and you take posts, and you take the current post, ... state.post, and you change whatever needs to be changed with the action.post. So that's it for this segment. Let's move on to lines 20 to 30. 24 actually is the next line. Constant store equals create store my reducer. We're calling this word store can be whatever. We can call it my store, whatever. My favorite store, store, whatever. This is a variable that can be changed. Equals create store my reducer. So this is the part that cannot be changed. It's create store. That's the method. And my reducer is just whatever you call your reducer, your combined reducer. Here is example of store.subscribe. Inside is a function, an arrow function. And in this case, I just console.logged just to debug. Console.log state updated, just a message. Console.log store.getState so that you can see the state. That is these lines. Let's see what else is left. There's not much, just line 31 to 34 to talk about. 31 to 34, these are just the dispatch. The dispatch is, I want to go in this order. To do, add a to do. And a to do to add, this is the payload. Remember the payload by milk. Here is a second dispatch. The action is add to do, and the payload is sleep some more. And the last one, sorry, is type. The action is add post, so that's this. Action is add post. And the payload is this post, egg hunt with Yoshi. Contains updated payload, see payload? That is the big discussion on Redux in React Native.